Alright, let's look at the homework 14, problem number 4. Alright, we want to write a triple integral in cylindrical coordinates for the volume inside the cylinder. Alright, so let's draw that. So you have the x-axis here and the y-axis here and the z-axis there. Alright, so we have a cylinder, so it's going to look kind of like this. So cylinder is radius is 2, so it's going to have 2 here and 2 here, and then it's going to look kind of like this. So we have a circle here. Right, then we have a cylinder. Right, something like that. Then I guess I'm gonna have a top which is looking like that. Alright, so we have cylinder there. Alright, maybe I'll do this so that, alright, oops. Alright, so that's a cylinder. Alright, radius is 2. And between z equals x squared, 2x squared plus y squared. So it's some kind of surface. It's actually go through the origin. So I guess, let's see. So it's going to look like this. Alright, then I guess it's cut off. So I guess it's going to look like this. Alright. Then also between that and xy plane. So xy plane is right here. So we have that. So above the xy plane and then below the surface inside the cylinder. So we're talking about this guy right here. So it's an inside cylinder. So those guys right here. And there's a hole, kind of like a hole inside. So you have a little cylinder with a hole inside there. All right. So this is the region we're talking about. All right. So we want to find the volume of this thing, and so we have a triple integral. All right. And area volume element for a cylindrical coordinate system is dr, r dr, d theta, dz. Alright, so what I'm going to do is actually I changed the order of integration a bit. I'm going to do a dz first. Alright, I'm going to do a dz. And then let's see, dz and maybe a ddr, and then we're gonna do d theta. All right. So let's fix the r and theta. So here r is fixed and theta is fixed. So here, so r is fixed and the theta is fixed. So we're starting from here. So we're starting from the xy plane up to the surface here. All right. So starting point xy plane is equation is z equals 0. So z equals 0 is the starting point, and all the way up to the surface here. All right. And I have to rewrite this in terms of a cylindrical coordinate system. All right, so z is equal to, all right, x is r cosine theta, so it's going to square that, r squared cosine squared of theta, plus y is r sine, so it's going to be r squared sine squared of theta. All right. So we can actually split it into r squared cosine squared theta. You have another one, r squared cosine squared of theta, and a plus r squared sine squared of theta. But this guy right here, we can factor out the r squared. Then you have cosine squared of theta plus sine squared of theta, which is 1. So what you get is just r squared. So this is actually r squared factored out. You have a cosine squared of theta plus 1. Right? So z is equal to r squared cosine squared of theta plus 1. Alright, so that will take care of that. And after that, r is going to go from, r is going to start from 0 all the way up to, so you're going to start from here and all the way up to the edge, which is the radius is 2. So r is going to be from 0 to 2. Alright, once you've done that, we can swing this thing all the way around once, so that theta is going to go from 0 to 2 pi. Alright, so this is z equals. Alright, so that's the triple integral, and I'll let you guys evaluate it. Alright, that's it. I hope that this will get you going.